26,000 light-years from where you sit, in the absolute stillness of the night, the heart of our galaxy beats with a violence that we are only just beginning to perceive. For eons, the center of the Milky Way was a place of shadow, hidden behind impenetrable veils of cosmic dust and thick, swirling gases that blocked the view of every telescope we had ever built. We knew something was there, a presence felt through gravity but never truly seen in its raw, unfiltered state. But then, the James Webb Space Telescope turned its massive, gold-plated mirror toward that distant core, piercing through the fog with infrared vision that sees heat where we see only darkness. What it captured in that stillness has terrified the scientific community. The telescope revealed structures that simply should not exist. Needle-like slivers of energy and matter piercing through the fabric of space, defying every mathematical explanation we have on record. Imagine a region of space so dense that 500,000 stars are packed into a volume smaller than the void between us and our nearest neighbor. In this crowded metropolis of light, the stars seem to scream. In their proximity, creating an environment of such intense radiation and gravitational pressure that light itself often finds it difficult to escape. Massive infant stars, 30 times larger than anything our models predicted for this region, are forming in the absolute darkness of infrared clouds. These are the titans of the cosmic nursery, born in a place where conditions should be too hostile for life or stability. If you have ever looked up at the night sky and felt a sense of peace, you must realize that at the very center of that beauty lies a churning, chaotic engine that operates on a scale of power that dwarfs our entire solar system. The Milky Way is not a static collection of stars. It is a living, breathing entity with a pulse that originates from its very center. When Webb poked into this heart, it didn't find the orderly, quiet progression of stellar life that we expected. Instead, it found a landscape of brilliant cyan outflows and ionized hydrogen that glows like a neon sign against the blackness of the void. The needles found there are perhaps the most disturbing. They are thin, sharp, and distinct, scattered across the region like splinters in the eye of the COs. MOs. Each one stretches for light years, pointing in random directions without any regard for the powerful magnetic fields that thread through the galactic center. In our standard understanding of physics, these structures should align with those fields, like iron filings following a magnet. But these needles ignore the rules. They point up, down, and sideways as if each young star is operating a total rebellion against its environment. This galactic heart is a place where the laws of nature are stretched to their breaking point. The density of stars is so high that they crowd together like people in a packed subway car, their gravitational fields overlapping and tugging at one another in a never-ending dance of chaos. In the quiet regions of the spiral arms where Earth resides, stars form slowly and methodically over millions of years. But here, near the screaming heart, stellar birth happens in what could be described as cosmic minutes. Gas is compressed so rapidly by extreme gravity that stars pop into existence like firecrackers. It is a gravitational meat grinder, a place where objects that wander too close are shredded by tidal forces, yet it is also the most prolific for GE in the galaxy. It is here that the heavy elements of our universe, the carbon in your bones and the iron in your blood, are forged at rates far higher than anywhere else in the cosmos. When we look at these images, we are not just looking at stars, we are looking at the pulse of reality itself. The heart of the Milky Way is anchored by a monster known as Sagittarius A, a supermassive black hole. 4 million times the mass of our Sun. It is a tear in the fabric of spacetime, a 14 million mile wide void that bends reality into a circle around itself. For decades we only caught glimpses of this beast through the blurry atmosphere of Earth. But Webb sat in the silence of space for 48 hours straight, watching the black hole breathe. The data revealed that this heart never has a steady state. It is always bubbling, always flickering with flares and eruptions that pump out more energy in a few hours than our Sun produces in days. It is a constant light show of terror and beauty, a bonfire at the center of a darkened room. The sensitivity of the James Webb Telescope allows us to hear the faint whispers of energy that bloom and fade before a human eye could even register them. There are medium flares that rage for hours and long oscillations that stretch across months, mimicking a slow cosmic breathing. 5 to 6 major flares erupt every single day from this central point, sending shock waves through the surrounding gas and dust. This swirling matter travels at speeds approaching the speed of light, creating friction so intense that the entire system glows white, radiation that would be lethal to any life nearby. Yet from our distance of 26,000 light-years, it appears only as a silent, flickering star in the constellation of Sagittarius. We are protected by the vastness of the distance, but the telescope has brought us close enough to feel the heat of the flames. As we move deeper into the analysis of this heartbeat, we find that the galactic center is not just a place of death and destruction, but a place of impossible creation. The stars that are born here are different. They are bigger, more violent, and shorter-lived than the stars in our neighborhood. They are the titans that seed the rest of the galaxy with the materials for life. However, their presence in such high numbers so close to the central black hole is a puzzle that currently has no solution. Every theory about how stars should form suggests that the intense radiation from the black hole should blow the gas away before it can ever collapse into a star. And yet, there they are, hundreds of thousands of them shining in defiance of the monster at the center. The needles, the flares, and the crowded stars all tell a story of a universe that is far more active and far more mysterious than we ever dared to imagine. We are seeing features for the first time that challenge the very foundation of our astronomical models. The resolution provided by Webb has turned what was once a blurry smudge of light into a complex, terrifying metropolis of celestial activity. As you listen to the rhythmic descriptions of these distant fires, let your mind drift into the scale of it all. Feel the distance between your quiet room and that screaming, vibrant heart. The heartbeat of the Milky Way is a reminder that we live on the edge of a great and powerful mystery. A mystery that is currently being unraveled, one infrared photon at a time, by a golden eye floating in the deep, cold dark. It is a strange comfort to know that even in the most violent regions of space, the E is a pattern, even if we do not yet understand it. The stars continue to ignite, the black hole continues to feed, and the needles continue to pierce the darkness. This is the first chapter of a new story for humanity, a story where the timeline is being rewritten and the maps are being redrawn. We are no longer looking at a static universe, we are looking at a dynamic, shifting, and often distant being reality. The heart of our galaxy beats on, hidden no longer, revealed in the soft, glowing light of the infrared spectrum, waiting for us to finally understand the rhythm of its ancient, violent pulse. James Webb launched on a quiet Christmas day in 2021, carrying with it the collective weight of thousands of human careers and the hope of a species eager to see its own beginning. For decades, we had constructed a beautiful, logical, and deeply comforting narrative of how the universe came to be. We believed that in the wake of the Big Bang, the cosmos was a dark, cooling soup of hydrogen and helium that slowly, over vast eons, began to clump together. The math was elegant and the timeline made sense. We expected that the first galaxies would be small, dim, and disorganized, fragile company. Collections of stars that would take billions of years to grow into the majestic spirals we see in our modern sky. We looked at the universe like a gardener looks at a forest. If every great oak must have started as a tiny, struggling sapling. But when the first data packets from Webb began to stream back to Earth, that entire story began to dissolve. What appeared on the screens of veteran astronomers did more than just surprise them. It made them question the very foundation of their life's work. Instead of the faint, tiny sparks of light they expected to find at the edge of time, they found a revolution. They saw galaxies that were big, bright, and fully formed, swarming across the images of the cosmic dawn like fully grown cities in a land where we expected only empty wilderness. These Galaxies had no business existing when the universe was barely born. According to the standard model of cosmology, the universe at 500 million years old, just 3% of its current age, should have been a place of simplicity. To find massive, mature galaxies at this stage is like finding a human infant born with a PhD and a mortgage. It felt wrong to physics, and it felt impossible too. The people who had spent their lives calculating the growth of the stars, the predictions said small and dim, but reality delivered massive and brilliant. Every theory about galaxy formation had assumed a slow, methodical process. We believed that first, tiny clumps of stars would gather in the dark. Over billions of years, these dwarf structures would smash together in violent mergers gradually, building mass. Eventually, after countless such collisions, galaxies like our own Milky Way would emerge as the finished products of a long and arduous construction. It was a timeline of patience. However, James Webb looked back 13 billion years and found that this timeline was essentially fiction. The galaxies it captured were already thriving and massive at a time when the universe should have been in its infancy. The foundation of our cosmic history shook. For some, it felt as though the floor had been pulled out from under the entire field of astronomy. Joel Leha, a researcher who studies these ancient structures, noted that these findings call the whole picture of early galaxy formation into question. This was not a minor confusion or a small error in calculation. It was a fundamental mismatch between what we thought we knew and what actually is. The telescope operates in the infrared spectrum for a very specific reason. Because the universe is expanding, the light from the most distant objects is stretched as it travels through space. Light that began its journey as visible light billions of years ago arrives at our doorstep as infrared radiation, heat. Human eyes cannot see this light, but Webb was designed to catch these ancient photons and catch them. Thousands of data points flooded in, each confirming the same impossible truth. The cosmic nursery looked more like a cosmic metropolis, dense and organized, at a time when it should have been nearly empty. When the results first came in, scientists naturally checked the instruments. They looked for calibration errors, ran diagnostics, and searched for any technical glitch that could explain such strange readings. They recalibrated the golden mirrors and checked the sensors again and again, but the readings remained stubbornly consistent. The galaxies remained impossible. Some researchers tried to find alternate explanations, hoping that perhaps these objects weren't galaxies at all, but something else, masquerading as mature stellar cities. Perhaps they were just unusually bright clusters of black holes or some other exotic phenomena we hadn't yet named. That hope lasted only until spectroscopy arrived. By breaking the light into its component wavelengths, astronomers can reveal an object's true nature, much like a fingerprint. The spectra confirmed the worst and most exciting fears of the community. Thank you. These were real galaxies, and they were massive. The implications of this discovery began to spread through the halls of science like cracks through thin ice. If galaxies could assemble this fast in the early universe, then our models of cosmic evolution were fundamentally broken. If stars were forming at rates 20 times faster than modern theory allows, then we had fundamentally misunderstood the birth of stars themselves. Even our understanding of dark matter, the invisible scaffolding that we believe holds the entire universe together, was suddenly under fire. If dark matter couldn't explain how these structures grew so quickly, then we might be wrong about the very gravity that governs reality. The telescope kept watching, and with every new observation the confusion only grew. Careers built on theories of slow growth began to crumble as the telescope revealed a universe that was in a much greater hurry than we ever imagined. This realization is terrifying and exhilarating. It suggests that the universe has secrets about time and matter that we haven't even begun to guess. We thought we were living in a mature, well-understood cosmos, but Webb has shown us that we are ill children trying to read a book in the dark. The Christmas revolution wasn't just about a new piece of technology. It was about the death of an old way of thinking. The timeline we use to map our place in the stars has been shattered, leaving us to rebuild our history from scratch. We are forced to ask how a galaxy can grow to the size of the Milky Way in just a few 100 million years. We are forced to reconsider the efficiency of gravity and the nature of early stars. As you reflect on this shattered timeline, imagine the sheer scale of the shift in our understanding. For over a century, we believed we had the basic blueprint of the universe figured out. We knew the age of the stars and how fast they grew. But now, we are looking at a past that is much busier, much brighter, and much more complex than our wildest dreams. The ancient universe was not a quiet, dark place of slow assembly. It was a frantic, energetic forge where massive structures appeared as if out of nowhere, defying the very clock of the cosmos. The data doesn't lie, but it does challenge us to be better, to think deeper, and to accept that the universe is far more mysterious than we ever dared to believe. The light from these impossible galaxies has traveled for 13 billion years to reach us, carrying the truth of a vanished era. It tells us that the universe did not wait for our permission to grow. It did not follow the slow rules we wrote for it in our textbooks. It moved with a ferocity and a speed that we are only now beginning to measure. As James Webb continues to stare into the deep, company, LD dark, we must prepare ourselves for the fact that this is only the beginning. The timeline is shattered, the revolution is underway, and the story of our origins is being rewritten in the golden glow of infrared light. We are witnessing the birth of a new cosmology, one where the impossible is simply the first thing we see when we open our eyes to the truth of the ancient dawn. To understand the true scale of the mysteries being unraveled, we must first understand the unique and powerful sight of the instrument that reveals them. Humans have evolved to see only a tiny sliver of the electromagnetic spectrum, a narrow band we call visible light. This is the light of rainbows, the blue of the sky, and the familiar glow of the sun. But the universe does not speak only in colors we can see. Most of the cosmos is whispered in frequencies that lie just beyond our reach, in the long, low waves of the infrared. For a telescope to look back to the very beginning of time, it cannot rely on visible light. It must possess an infrared eye, a golden mirror capable of catching ancient photons that have been traveling through the void for over 13 billion years. These photons are the oldest messengers in existence, and they carry with them the secrets of a universe that has long since changed its face. The reason we must use infrared to see the ancient past is a phenomenon known as cosmological redshift. Imagine a single photon of light leaving a newborn galaxy billions of years ago. At that time, the light might have been a brilliant blue or a sharp ultraviolet, vibrating with high energy and short wavelengths. But as that photon travels toward us, the universe itself is expanding. Space is stretching in every direction, and as space stretches, it pulls on the light traveling through it. The wavelength of that photon is drawn out, becoming longer and longer. By the time that light reaches our solar system, it has been stretched so far that it is no longer blue, it has shifted through the red end of the spectrum and into the infrared. To our eyes, that light has become invisible. To a traditional telescope, that galaxy has simply disappeared into the darkness. But to the James Webb Space Telescope, that light is a warm, detectable glow. Catching these ancient photons is a task of incredible delicacy. The signals Webb searches for are so faint that they represent a fraction of the energy of a single snowflake hitting the ground. To detect such whispers of heat, the telescope itself must be incredibly cold. If the telescope were warm, its own heat would drown out the signals from the distant stars, like trying to hear a whisper in the middle of a thunderstorm. This is why Webb is stationed nearly 1 million miles from Earth at a point of gravitational stability c, called the second Lagrange point. There, it sits in the permanent shadow of a massive sunshield, 5 layers of specialized material the size of a tennis court. On the side facing the sun, the temperature is hot enough to boil water. On the side where the mirrors sit, the temperature is a staggering 400 degrees below zero. In this absolute artificial winter, The infrared eye can finally open. The telescope's mirror is a masterpiece of human engineering composed of 18 hexagonal segments of beryllium coated in a thin layer of pure gold. Gold is used not for its beauty, but because it is one of the most efficient reflectors of infrared light in the known world. When an ancient photon finally reaches the telescope after its billion-year journey, it bounces off this golden surfer, CE, and is focused into sensitive instruments that can count every individual particle of light. These instruments are so precise they can detect the heat of a bumblebee on the surface of the moon. It is through this level of sensitivity that we are finally seeing the cosmic dawn, the era when the first stars flickered to life and ended the long, dark ages of the early universe. Without this infrared eye, we would be forever blind to our own origins. Staring at a black wall where there is actually a vibrant, crowded history, the infrared eye does more than just see across distance, it sees through obstacles. One of the greatest challenges in observing our own Milky Way is the presence of cosmic dust. Invisible light, the center of our galaxy is hidden behind thick, dark clouds of soot and silicates that block nearly all light. These dust clouds act like a thick fog, preventing us from seeing the stars behind them. However, infrared wavelengths are longer than the particles of dust themselves. Instead of being blocked, the infrared light simply slips past the dust, much like a radio signal passes through the walls of a house. This allows Webb to peer directly into the heart of nurseries and the chaotic centers of galaxies. We are seeing stars in the very act of being born, wrapped in their dusty cocoons, revealing a level of detail that was once thought to be technically impossible. Each photon caught by Webb is a piece of data that confirmed the impossible. When we look at the images produced by this infrared eye, we are essentially looking at a heat map of the high story of time. We see where the gas is hottest, where the gravity is strongest, and where the first elements were forged. The thousands of data points that flood into the computers of astronomers are not just numbers, they are the ghosts of a vanished era. They tell us that the infant universe was not a cold, empty void, but a place of intense activity and rapid growth, the organized, mature city of stars we find in the deep past are visible only because we finally have the right kind of vision to see them. We are no longer limited by the biological constraints of our own eyes. We have built an extension of our consciousness that can see the heat of the Big Bang's afterglow. As you contemplate the power of this infrared eye, think about the photons themselves, these tiny packets of energy. I have been flying through the vacuum of space at the speed of light since before the Earth even existed. They have passed through empty voids and skipped past ancient nebulae, carrying their message across the staggering scale of the cosmos. After 13 billion years of travel, they finally struck a golden mirror and gave up their energy so that we might understand where we came from. It is a profound connection between the modern human mind and the primordial fires of the beginning. The James Webb Telescope is not just a camera, it is a time machine that uses heat as its fuel and light as its guide. The revolution in our understanding of the timeline is entirely due to this ability to see what was once hidden. The impossible galaxies and the screaming stars are only terrifying becks. So we can finally see them clearly enough to realize they don't fit our old maps. With every new image, the infrared eye reveals more cracks in the old theories. It shows us a universe that is far more interconnected and far more efficient than we ever suspected. We are learning that the vacuum of space is not truly empty, but filled with the radiation of a billion histories, all waiting to be seen, aught by a mirror cold enough to perceive them. In the silence of the second Lagrange point, the telescope continues its vigil. It does not blink and it does not tire. It simply waits, its golden segments aligned with perfection, catching the light of 1,000 dawns. We are the first generation of humans to see this light, to know the true colors of the early universe, and to hear the infrared heartbeat of the stars. The infrared eye has changed how we view the night sky forever. We now know that the darkness is an illusion, a result of our own limited vision. Behind the blackness of the night, The universe is ablaze with a heat that has been traveling since the dawn of time, and we are finally, at long last, beginning to see the fire. Our journey now takes us back from the edge of time, to our own cosmic backyard, to a place of shadows and gravity that anchors everything we know. At the very center of the Milky Way, 26,000 light-years away, lies a heart that is not made of rhythmic muscle, but of an ancient and terrifying power. This is Sagittarius A, a supermassive black hole that sits like a silent sovereign over the hundreds of billions of stars that make up our galaxy. For decades, we spoke of this place in hushed, theoretical tones, catching only the briefest, blurriest glimpses of its influence. To the human eye and even to our most powerful traditional telescopes, it was a ghost, a presence we knew was there only because of the way the stars near it danced in frantic, impossible orbits. We called it a sleeping giant, assuming that after billions of years, it had settled into a quiet, dormant state. But as the James Webb Space Telescope turned its golden eye toward this central void, the sleeping monster began to reveal a much more active and chaotic nature. The scale of Sagittarius A is difficult for the human mind to grasp without a sense of deep, quiet reflection. Imagine an object 4 million times the mass of our Sun, compressed into a region of space so small that it would fit well within the orbit of Mercury. It is a point of infinite density, a tear in the very fabric of space-time, where the laws of physics as we understand them simply cease to function. Around this dark heart, reality itself is bent and twisted. Gravity here is so strong that not even light, the fastest thing in the universe, can escape its pull once it crosses the invisible threshold known as the event horizon. For years, we viewed this black hole as a static, unchanging sinkhole, a passive consumer of whatever happened to drift too close. However, when Webb pointed its near-infrared camera at the galactic center in 2023, it watched for 48 hours straight, capturing multiple sessions across a full year. What it found was not a silent tomb, but a boiling cauldron of activity that never seems to reach a steady state. Fahad Yousefzadeh, a leading researcher in these observations, described the heart of our galaxy as always bubbling with activity. This was a revelation that shattered the idea of a dormant monster. The black hole does not just sit in the dark, it throws a non-stop light show of flickers, flares, and eruptions. Through the infrared vision of Webb, we can see the accretion disk, a swirling maelstrom of gas and dust that orbits the black hole at speeds approaching the speed of light. As this matter is pulled toward the event horizon, it is crushed and heated to millions of degrees. Friction in this cosmic drain creates a glow so intense that it functions like a bonfire in the middle of a dark forest. The activity operates on multiple timescales, ranging from short bursts that last mere seconds to long oscillations that stretch across months, mimicking a slow, rhythmic cosmic breathing. We are witnessing the metabolism of a monster, a constant exchange of energy and matter that defines the very center of our existence. Previous observations from ground-based telescopes had missed most of this chaos. Earth's atmos. Fear acts like a frosted window, scrambling the delicate signals of heat and radiation coming from the galactic core. Earlier space telescopes, while helpful, lacked the extreme sensitivity required to see the faint flickers between the major flares. They only caught the most blinding eruptions, leaving us with a false sense of a black hole that spent most of its time in silence. But James Webb's infrared vision cuts through the cosmic dust like a hot knife through wax. Its sensitivity picks up even the most minute variations in light, revealing that 5 to 6 major flares erupt every single day. Between these massive bursts, smaller sub-flares pepper the accretion disk constantly. The heart of our galaxy is screaming in a frequency we are only just beginning to tune into. The sound is nay of constant, energetic upheaval. The source of this activity is a complex dance of magnetic fields and plasma. Imagine trillion-ton car crashes happening every few seconds as blobs of gas are forced together by the immense gravitational and magnetic pressures. When these magnetic field lines within the disk clash and reconnect, they release stored energy in violent bursts, accelerating particle to nearly the speed of light. These particles shoot away from the disk as blazing jets, carving paths through the surrounding nebula. It is a place of perpetual motion where nothing is ever truly still. The black hole feeds constantly, drawing in the surrounding gas and dust to fuel its eternal fire. It is a paradox of nature, an object defined by its darkness that produces the most brilliant lig T in the galaxy. As we watch this monster wake, we must realize that Sagittarius A is the reason the Milky Way looks the way it does. Its gravity acts as a tether, influencing the orbits of millions of stars and helping to maintain the structure of our spiral home. Yet it is also a source of profound instability. The radiation pouring out from the accretion disk is powerful enough to strip the atmospheres off planets and prevent the formation of life for thousands of light years around it. We live in the quiet suburbs of the galaxy, far enough away to be safe from the monster's breath, but close enough to feel its pull. The James Webb observations have given us a front-row seat to the most dangerous place in the universe, allowing us to study the limits of reality from the safety of our own world. The terror of Sagittarius A is not just in its power to destroy, but in its ability to distort time itself. Near the event horizon, time slows down significantly relative to the rest of the galaxy. A few minutes spent near the edge of that dark heart would equate to years passing back on Earth. It is a place where the past, present, and future seem to blur into a single gravity-heavy. Through the data provided by Webb, we are seeing the light from flares that happened 26,000 years ago, yet the information feels as fresh and urgent as a heartbeat. We are looking at the ancient history of our galaxy's heart, watching the flares and flickers that shaped the environment of the core long before humans ever walked the Earth. The more we look at this supermassive black hole, the more we realize that it is not an isolated object, but the primary engine of a vast interconnected system. The gas it rejects in its flares eventually cools and becomes the raw material for new stars in the surrounding regions. The energy it releases sculpts the clouds of the galactic center, creating the strange needle-like structures and dense stellar nurseries we discussed here. The monster is both a consumer and a creator, a dark sun that provides the energy for the chaos of the core. The James Webb Space Telescope has finally allowed us to see the monster for what it truly is, a restless, bubbling center of activity that never sleeps and never rests. In the quiet of our own lives, it is easy to forget that we are orbiting such a magnificent and terrifying power. Boo! T, the heartbeat, is there, flickering in the infrared, a constant reminder of the scale of the cosmos. Sagittarius A has woken up in our scientific understanding, transforming from a theoretical point on a map to a living, breathing reality. We are the first generation to see its flares in such unprecedented detail, to measure its breathing and to witness the trillion-ton crashes of its accretion. Disk. The sleeping monster is gone, replaced by a vibrant and chaotic heart that beats with the energy of a million suns, hidden no longer from the curious eyes of humanity. In the vast, silent reaches of the cosmos, time is usually measured in millions or billions of years, a slow and patient progression that dwarfs the fleeting span of a human life. However, when the James Webb Space Telescope earned its unwavering gaze toward the center of our galaxy, it found a place where time seems to accelerate into a frantic, chaotic blur. For 48 hours, the telescope stared into the heart of the Milky Way, capturing a sequence of events so violent and rapid that astronomers have come to describe the region as a cosmic bonfire. This was not a singular event, but a continuous roiling storm of energy that never settles, never cools, and never reaches a state of peace. In those 2 days of observation, the data revealed a landscape of pure, unadulterated chaos, where the laws of thermodynamics are pushed to their absolute limits and the vacuum of space is filled with the roar of invisible fires. The concept of a cosmic bonfire is more than just a poetic metaphor. It is a literal descry of the environment surrounding our central black hole. Imagine a swirling vortex of plasma, gas, and dust, heated to temperatures so extreme that they defy conventional measurement. This matter is trapped in the gravitational well of Sagittarius A, moving at a significant fraction of the speed of light. As these particles collide, they release bursts of radiation across the entire electroma. Kinetic spectrum, but it is in the infrared that the true intensity of this bonfire becomes visible. Through Webb's golden mirror, the galactic center appears as a brilliant, flickering beacon, a source of heat and light that outshines thousands of ordinary suns combined. In this high-energy cauldron, the very atoms of the universe are stripped of their electrons and whipped into a frenzy by magnet. I see forces that are millions of times stronger than the magnetic field of the Earth. During the 48 hours of intense observation, the telescope recorded 5 to 6 major flares every single day. These were not mere flickers, they were massive eruptions of energy, each one equivalent to the power of 1,000,000 nuclear bombs detonating simultaneously. These flares are the result of magnetic R-E connection, a process where the tangled magnetic field lines of the accretion disk snap and reform, releasing their stored energy in a sudden, violent burst. For a brief moment, a single flare can outshine the entire center of the galaxy, casting a harsh, ionizing light over the surrounding stars. Researchers monitoring the data stream were stunned by the frequency of these events. It was as if T black hole was gasping for air, each flare a sudden inhalation of energy followed by a chaotic release of radiation. Between these gargantuan eruptions, the cosmic bonfire is peppered with thousands of smaller sub-flares, quick flashes of light that appear and vanish in the blink of an eye. This constant background noise of activity suggests that the accretion disk is never at rest. It is a CE of perpetual turbulence, where blobs of gas the size of planets are constantly crashing into one another, compressed and torn apart by the competing forces of gravity and magnetism. The researchers compared these interactions to a trillion-ton car crash happening every few seconds, a never-ending cycle of destruction and energy release. This is the reality of the galactic center, a place where stability we enjoy in our solar system is replaced by a relentless, grinding chaos that would be lethal to any form of life we can imagine. The James Webb Telescope's infrared vision is what makes this observation possible. Earlier instruments, limited by their sensitivity and the interference of Earth's atmosphere, saw only the brightest peaks of this activity, leading us to believe that the center of the galaxy was a relatively quiet place punctuated by rare events. But Webb has shown us the truth. The quiet periods are themselves filled with a low-level energetic churning. The bonfire is always burning, we simply didn't have the eyes to see the embers until now. The telescope's ability to cut through the thick clouds of cosmic dust allowed us to see the base of the flame, the very inner edge of the accretion disk, where matter makes its final, frantic orbit before disappearing forever into the black hole's event horizon. As the 48-hour observation period progressed, the data revealed that the activity operates on multiple timescales. There is a slow, rhythmic breathing to the bonfire, long oscillations of brightness that stretch across hours and days, suggesting large E-scale movements in the surrounding gas clouds. Overlaying this rhythm are the sharp staccato bursts of the flares, creating a complex symphony of radiation that encodes the history of the black hole's most recent meals. Every flare is a signature of something being consumed, a cloud of hydrogen, a stray asteroid, or perhaps even a planet that wandered too close to the gravitational meat grinder. We are witnessing the digestion of the cosmos, a process that turns solid matter into pure, blinding energy. The heat from this cosmic bonfire has a profound effect on the surrounding space. It creates a bubble of ionized gas that extends for light years in every direction, pushing back the cooler, darker clouds of the interstellar medium. This heat prevents new stars from forming in the immediate vicinity of the black hole, yet strangely, it also provides the energy that triggers star formation further out. Bonfire is a sculptor, using its radiation to carve the pillars and filaments of gas that we see in the Webb images. It is a terrifying paradox of nature. The very energy that destroys matter near the black hole is responsible for the birth of new stars in the surrounding nurseries. The chaos of the center is the engine that drives the evolution of the entire galaxy. By the end of the 48-hour window, the science team realized they were looking at a system that never reaches a steady state. Most astronomical objects seek a form of equilibrium, but the heart of the Milky Way is defined by its lack of balance. It is a non-stop light show of flickers and eruptions, a play. CE, where the concept of normalcy is synonymous with turbulence. The cosmic bonfire is a reminder that our universe is not a museum of static objects, but a laboratory of extreme physics. The data collected in those 2 days will provide work for theorists for decades, as they try to model the complex fluid dynamics and magnetic interactions that create such a sustained level of chaos. As you drift into the thought of this ancient, distant fire, imagine the sheer scale of the energy being released. Even though we are 26,000 light-years away, the radiation from those flares is hitting the telescope's sensors with a clarity that makes the distance seem to vanish. We are huddled around the light of this cosmic bonfire, warming ourselves with the knowledge it brings, even as we are terrified by the power it represents. It is the central fire of our house, the source of the heat that forged our world, and the final destination for all things that wander too close to the dark. The 48 hours of chaos were just a single moment in the life of the galaxy, but for us, they were a window into a reality that is as beautiful as it is disturbing. The heartbeat of the Milky Way, the shattered timeline of the early universe, and the golden infrared eye all culminate in this single burning point of interest. The cosmic bonfire is the ultimate expression of the James Webb Telescope's mission, to see what cannot be seen and to understand what seems impossible. The chaos of the galactic center is no longer a mystery hidden behind a veil of dust. It is a visible, measurable reality that challenges our understanding of how galaxies function. The bonfire burns on, flickering in the deep infrared silence, a constant, violent reminder of the magnificent power that lies at the very heart of the place we call home. In the quiet, light-years-wide expanse of the galactic center, where the infrared glow of 500,000 stars creates a tapestry of unimaginable density. James Webb's golden mirror captured something that had never been seen before. Within a region known as Sagittarius C, a star-forming zone sitting just 300 light-years from the screaming heart of the Milky Way, the telescope revealed a series of structures so sharp and so thin that they have come to be known as the needles. These are not the rounded, billowing clouds of gas we have come to expect from cosmic nebulae, nor are they the spiraling arms of a distant galaxy. Instead, they are narrow, cyan-colored slivers of ionized hydrogen that pierce through the darkness like splinters of light. There are dozens of them, scattered across the region without any discernible order, and they represent one of the most significant challenges to our understanding of galactic physics that we have encountered in the modern era. To understand why these needles are so disturbing to the scientific community, one must first understand the invisible forces that govern the center of our galaxy. Space is not empty, it is threaded with powerful magnetic fields that act as a hidden scaffolding for matter. Near the supermassive black hole at our galaxy's core, these magnetic fields are incredibly strong, functioning like a cosmic loom that weaves gas and dust into specific patterns. In every other part of the universe we have studied, when young stars form and shoot out jets of material, those jets follow the lines of the local magnetic field. It is a fundamental rule of astrophysics. Charged particles and ionized gases are obedient to the pull of magnetism. We expected that any structures found in Sagittarius C would be aligned, pointing in a singular, organized direction dictated by the overwhelming magnetic influence of the galactic center. But needles totally ignore this rule. Each needle points in a different random direction, up, down, sideways, and diagonal, with a defiance that seems to suggest the magnetic fields simply do not exist in their vicinity. They cut across the expected pathways of energy like rebels in a strictly governed city. This lack of organization is more than just a visual curiosity. It is a direct contradiction of the math that explains how matter behaves near a galactic core. Samuel Crowe, the principal investigator for these observations, noted that there has never been infrared data with this level of resolution and sensitivity before, and as a result, we are seeing features that refuse to follow the established laws of the neighborhood. The needles stretch for light years, maintaining their razor-sharp focus over distances that would normally cause any gas cloud to dissipate or curve. They are straight, they are distinct, and they are utterly unexplained. One possible explanation is that these needles are the outflows from protostars, infant suns still hidden deep within their dusty cocoons. When a star is born, it often sheds its excess angular momentum by shooting jets of material perpendicular to its rotation. If Sagittarius C is as active as the Webb images suggest, there could be dozens of these infants firing their cosmic cannons at the same time. However, even this explanation falls short. Even if they are stellar jets, TEY should still be influenced by the magnetic environment. The fact that they remain perfectly straight while pointing in random directions suggests that the local turbulence of the gas is so intense that it is somehow shielding these structures from the magnetic loom, or perhaps the stars themselves are forming with such violent kinetic energy that they simply tear through the magnetic fabric BEF. Or it can redirect them. The scale of the needles is as impressive as their mystery. Each sliver of light represents a vast amount of energy, carving a path through the ionized hydrogen that glows in a brilliant cyan hue in the processed images. This region of the galaxy is a place of extreme contrasts. While the needles are thin and sharp, they are surrounded by massive billowing clouds of emis, psion that extend far beyond what the visible stars should be able to produce. This suggests that there is a hidden power source within Sagittarius C, perhaps a cluster of massive stars still buried in the infrared dark clouds, or some other process that is ionizing the hydrogen at a scale we didn't think was possible. The needles sit in the middle of this glowing fog, appearing as sharp, unnatural lines in a world of soft, organic curves. As you reflect on the mystery of these needles, imagine the sheer chaos of the environment they inhabit. Just a short distance away, the supermassive black hole is flickering and flaring, sending waves of radiation through the space between stars. The gravity in this region is so strong that it stretches and squeezes the gas clouds, yet the needles remain straight. The magnetic fields are trying to pull everything into a neat, organized flow, yet the needles point wherever they wish. They are proof that our maps of the universe are still incomplete. We are looking at a localized phenomenon that defies the global rules of the galaxy, a hidden layer of reality that only became visible once we had a telescope sensitive enough to see the heat of indivi, jewel splinters of light. The existence of the needles suggests that the galactic center is a far more fragmented and turbulent place than we previously assumed. Instead of a cohesive system where everything moves in concert, it appears to be a collection of individual actors, each one carving its own path through the void. This fragmentation matters because it changes how we calculate the birth ray, T of stars, and the distribution of elements. If the magnetic fields are being ignored or bypassed by these structures, then our simulations of how the Milky Way evolved are missing a key component. We are seeing a breakdown of order at the very heart of our home, a place where the needle mystery serves as a reminder that nature always has another layer of complexity waiting to be discovered. Research teams are currently running simulations and testing new hypotheses to see if they can replicate these needles using traditional physics. So far, nothing fits perfectly. To create a structure that is both light years long and perfectly straight without magnetic alignment requires a set of conditions that are rare in the modern universe. Perhaps these needles are a relic of a past Khaleesi, or perhaps they are the result of a specific type of acoustic wave moving through the dense gas of the core. Every time a scientist proposes a solution, the sheer randomness of the needle's orientation sends them back to the drawing board. They are a beautiful, glowing cyan puzzle, etched into the darkness by a hand we do not yet recognize. As James Webb continues to observe Sagittarius C, the needles remain as one of its most haunting discoveries. They are a visual representation of the disturbing nature of the galactic center, a place where things that shouldn't exist are found in abundance. They remind us that the closer we look at the universe, the more we find it defies our expectations. The needles are not just lines of gas, they are the fingerprints of a physical process that we are only just beginning to name. They stand as silent sentinels near the screaming heart of the galaxy, pointing toward a truth that remains just out of our reach, waiting for the next breakthrough in our understanding of the cosmic dark. The beauty of the needles lies in their precision, but their power lies in their mystery. In a universe that we thought we had categorized and mapped, these splinters of light have carved out a space where we must admit that we are still learners. They are a quiet, glowing defiance of the magnetic scaffolding of reality, a cyan-colored question mark at the center of the Milky Way. As we move forward into the more crowded and violent regions of the core, the memory of these straight, random, and impossible structures will linger, a reminder that in the deep infrared, the needles are always piercing the veil, showing us that there is still so much left to see and even more to understand. In the quiet suburbs of the galaxy where our own solar system resides, space is a vast, lonely expanse of silence. Our nearest stellar neighbor, Proxima Centauri, sits over 4 light-years away, a distance so immense that it takes years for even light to cross the void. We are accustomed to a universe of isolation, where stars are distant pinpoints of light separated by trillions of miles of nothingness. But as we move deeper toward the core, toward a region known as Sagittarius C, the rules of personal space are discarded entirely. Through the infrared lens of the James Webb Space Telescope, this region reveals itself not as a void, but as an impossibly crowded stellar subway. Here, in a patch of space only 50 light-years wide, Webb has captured the light of approximately 500,000 stars. 500,000 nuclear furnaces are packed into a volume so small that, from their perspective, the sky would never be dark. It is a metropolis of light, a dense and frantic gathering where the very concept of distance is shrunk to astronomical insignificance. The density of Sagittarius C is difficult to fathom from our perspective of galactic solitude. In this stellar subway, stars do not live out their lives in isolation, they crowd together like commuters on a platform, their gravitational fields constantly overlapping and tugging at one another. This extreme proximity changes the fundamental nature of how a star exists. In the sparse regions of the spiral arms, a star might go its entire multi-billion-year life without ever encountering another object of significant mass. But here, near the heart of the Milky Way, stars pass close to one another with a frequency that would be terrifying in our neighborhood. Gravitational nudges are constant, altering orbits and sending stars on new, chaotic trajectories. Some stars are ejected from the region entirely, flung out into the darkness by a gravitational slingshot, while others are pulled deeper into the crushing gravity well of the central black hole. It is a high-stakes game of cosmic billiards, where every movement influences 1,000 others. What makes this crowded environment even more remarkable is the speed at which life and death occur. In the quiet regions of the galaxy, the birth of a star is a patient affair. A cloud of gas collapses under its own weight, taking millions of years to gather enough mass to ignite its core. The process is stable, methodical, and predictable. However, in the crowded subway of Sagittarius C stellar, birth happens in what could be described as cosmic minutes. The environment is so dense with gas and so heavy with gravity that the pressure to ignite is overwhelming. Gas clouds are compressed rapidly by the collective pull of 500,000 stars, and the looming presence of Sagittarius A stars pop into existence with a ferocity that defies our standard models. It is as if the universe has bypassed the long construction phase and jumped straight to the finished product. These stars are born into a neighborhood of intense radiation and crushing tidal forces. yet they continue to ignite in numbers that challenge our understanding of physics. This density poses a paradox that astronomers are still struggling to resolve. According to basic physics, the intense radiation from 500,000 stars should heat the surrounding gas clouds to such a degree that they expand and resist further compression. Hot gas is difficult to collapse. It wants to fly apart rather than become a star. By all our calculations, the center of the galaxy should be a place where star formation is suppressed by the sheer heat of its own population. Yet Webb's captured reality shows otherwise. Stars are forming here faster than almost anywhere else in the galaxy. Gravity seems to be working overtime, winning the battle against the heat and radiation of the crowd. It is a gravitational meat grinder that, instead of only destroying, functions as the most prolific forge in the cosmos. The subway is not just crowded with living stars, it is filled with the energetic potential of thousands more waiting to ignite. The interaction between these stars creates an environment unlike anything in the universe. Imagine standing on a planet in the middle of Sagittarius C. Your night sky would not be a black velvet curtain with scattered diamonds. It would be a brilliant, glowing canopy of multicolored suns. Some would be so close that they would appear as distinct disks, casting multiple shadows on the ground. The sky would be perpetually bright, a twilight that never fades into true night. But this beauty would come at a terrifying price. Radiation levels in such a dense cluster would be staggering. The constant bombardment of X-rays and ultraviolet light from nearby massive stars would likely prevent the formation of stable atmospheres or complex chemistry as we know it. The stellar subway is a place for stars to thrive, but it is a hostile wilderness for anything as fragile as a planet or a person. The James Webb Telescope has revealed that this crowding also leads to a process known as spaghettification on a grand scale. While we often associate this term with objects falling directly into a black hole, the tidal forces in Sagittarius C are strong enough to affect the stars themselves as they navigate the dense cluster. When two stars pass close enough to one another, the gravity of the more massive one can pull harder on the near side of its companion than the far side. This stretches the star, elongating its shape before eventually tearing it into a stream of hot gas. This gas then becomes part of the shared atmosphere of the cluster, a swirling fog of hydrogen and helium-T. Hat feeds the birth of the next generation of stars. In the crowded subway, nothing is wasted. The death of one star is the immediate fuel for the birth of another, a rapid and violent cycle of recycling that keeps the region in a state of perpetual animation. Samuel Crowe, who has analyzed these images, raised a fundamental question that strikes at the heart of our understanding of cosmic evolution. Are more massive stars formed in the center of our galaxy compared to the edges of its spiral arms? The answer to this question has profound implications for the chemistry of the entire universe. Massive stars are the cosmic forges of heavy elements. They live fast and die young in spectacular supernova explosions, seeding the surrounding space with carbon, oxygen, and iron. If the crowded subway of Sagittarius C preferentially creates these massive titans, then the center of the galaxy is the primary engine of chemical complexity. It is the factory where the ingredients for life are produced at an accelerated rate, even if life itself cannot survive in the factory's heat. We are seeing the source of our own atomic makeup in the middle of this chaotic, crowded light. The sheer number of stars visible in Webb's image represents only what the telescope can currently detect. Countless more likely hide behind the thick infrared dark clouds that dot the region like black holes in the tapestry. These clouds are future stellar nurseries, places where the next generation of commuters is being prepared for the journey. The true population of Sagittarius C probably exceeds 1 million stars, all packed into a volume that would be considered empty space in our neck of the woods. This level of density ensures the region will remain a place of constant change. There is no steady state here. There is only the flow of matter and energy, the collision of orbits, and the endless scream of 500,000 suns shining into the void. As you contemplate the scale of this stellar metropolis, let your mind drift into the rhythmic chaos of it all. The subway of Sagittarius C is never silent and never still. It is a place where gravity is the ultimate conductor, moving 500,000 performers in a dance that is both beautiful and terrifying. James Webb has given us a ticket to view this performance, showing us that our quiet, lonely corner of the universe is the exception, not T. He rule. At the heart of our galaxy, the crowd is everything, and the light is so thick it feels like a physical presence. The stellar subway is a reminder that the universe is far busier than we ever dared to imagine, and that even in the deepest darkness, there are places where the stars are so close they can almost touch. At the heart of the darkness, far from the bustling light of the stellar subway, something massive and terrifying is being born. Deep within an infrared dark cloud near the region of Sagittarius C, the James Webb Space Telescope has fixed its gaze on a void that is not a void at all, but a cradle for a titan. This is the birthplace of a monster star, an infant celestial entity that is already Thank you times as massive as our Sun, and it hasn't even finished growing. To the human eye, this region appears as a hole in the universe, a black smudge against the tapestry of 1,000,000 stars where light itself seems to go to die. The dust here is so thick and so cold that it blocks nearly every photon of background starlight, creating a pocket of absolute silence in a galaxy that is otherwise scream in with energy. But Webb's infrared vision can see the heat of the struggle within, revealing a protostar that is pulling in gas with such ferocity that it is reshaping the very fabric of its neighborhood. This infant monster hides within its cave of dust, but it cannot hide its influence. Even though we cannot see the star directly, we can see the wake it leaves behind. As the protostar gathers mass from the surrounding cloud, it spins with incredible speed, creating powerful magnetic fields that act like cosmic slingshots. These fields grab a portion of the incoming gas and hurl it away in twin jets, shooting out from the poles of the star and into the surrounding nebula. These outflows glow at the edges of the dark cloud, creating shock waves that reveal the monster's presence, like the footprints of a predator in the snow. To find a star this massive, while it is still in its formative stages, is a rare and unsettling discovery for astronomers. Most stars in the universe, like our own Sun, are relatively modest in size, but the galactic center provides the extreme density and crushing gravity necessary to build a true titan of the void. The conditions required to create such a monster are as unique as the star itself. In the quiet outer arms of the Milky Way, gas is sparse, and stars tend to stop growing once they reach a certain threshold. But here, near the screaming heart of the galaxy, the sheer abundance of gas and the relentless pressure of gravity allow stars to exceed every normal limit of physics. This protostar is a cosmic mayfly, a creature destined for a life that is as spectacular as it is brief. While a typical star like our Sun might shine for 10 billion years, a Titan 30 times its mass will burn through its fuel at a terrifying rate. These monsters live fast and die young, surviving for only a few million years, a mere blink in the eye of the cosmos. They are the brilliant, violent anomalies of the universe, blazing with a light so intense that they can outshine entire clusters of ordinary stars. The birth of such a star is not a peaceful event. As the monster grows, it begins to push back against the very cloud that created it. The intense radiation from the core starts to heat the surrounding dust, blowing away the outer layers of the cradle in a process that will eventually leave the star exposed and brilliant. But for now, it remains huddled in the darkness, a secret powerhouse that is preparing to ignite the fires of nuclear fusion on a scale we can imagine. This Titan will become a nuclear furnace of unimaginable proportions, converting hydrogen into helium with such efficiency that it will create a bubble of empty space around itself. It is a war between the inward pull of gravity and the outward pressure of radiation. At 30 solar masses, the stakes of this battle are high enough to affect the evolution of the entire surrounding SE. Cetor, When this star finally finishes growing and igniting its core, it will become one of the most dangerous objects in the galaxy. Its light will be so energetic that it will strip the electrons from every atom of hydrogen for light years around, creating a glowing nebula of ionized gas. But the real fear is how this star will end. Because it is so massive, it will not fade into a quiet white DW. Instead, it will reach a point where it can no longer support its own weight. Gravity will win the final battle, and the star will collapse in seconds. This collapse will trigger a supernova explosion so powerful that it could be seen from across the universe. For a brief moment, this single dying titan will release more energy than all the other stars in the Milky Way combined, seeding the sea. Cosmos, with heavy elements like carbon, oxygen, and gold, the very building blocks of life and planets. If the core remains massive enough after the explosion, it will undergo a second collapse, disappearing from the visible universe entirely and leaving behind a stellar mass black hole. These are the smaller siblings of the monster at the galaxy's center, and they populate the region like ghosts of a violent past. This cycle of massive birth and violent death is the engine that drives the chemical evolution of our home. The titan currently forming in the dark cloud is just the latest in a long line of monsters that have lived and died in the shadows of Sagittarius C. Its existence proves that the galactic center is still a vibrant, active forge capable of producing titans that defy the standards of the rest of the galaxy. Around this primary monster, the infrared dark cloud reveals smaller signatures of other proto-stars, an entire generation of giants forming simultaneously in the gloom. It is a nursery of titans, a place where the next generation of cosmic engines is being tuned for their brief, brilliant lives. Each of these infants is pulling in gas, growing heavier and racing toward the moment of ignition. The density of the cloud helps facilitate this rapid growth, as the collective gravity of the region works overtime to compress the gas. In any other part of the galaxy, these clouds might dissipate before they could form such massive stars, but the environment of the core is one of such extreme pressure that the clouds are forced to give birth to monsters. As you contemplate this titan in the void, let your mind sit with the silence of that dark cloud. Imagine the immense weight of the gas pressing down on that central point, and the heat beginning to stir within the shadows. It is a moment of profound potential, a silence that precedes a storm of light. James Webb has allowed us to look into this cradle and see the monster before it wakes, giving us a glimpse into a process that was once hidden behind an eternal veil of dust. We are seeing the raw power of the universe at its most efficient and its most terrifying. The titan is growing, the void is filling, and soon the darkness will be replaced by a light that will sculpt the very stars around it. The titan in the void is a reminder that even in the most desolate and dark corners of the galaxy, life, or at least the energy that sustains it, is always finding a way to ignite. The monster star is not just an object of terror, it is a source of creation, a forge that will one day provide the atoms for worlds we will never see. It is a spectacular, short-lived testament to the power of gravity and the abundance of the core. As Webb continues to watch, the dark cloud will slowly be torn apart by the monster within, revealing a brilliant new sun that will shine for a moment in cosmic time before returning to the darkness from which it came. The cycle of the titans continues, and we are finally here to witness the birth of the massive few that rule the dark. As we move our gaze away from the local violence of our own galactic core and look out into the farthest reaches of the observable universe, we encounter a mirror that reflects our own home in a way that defies every law of cosmic aging. Through the deep field images of the James Webb Space Telescope, astronomers have counted over 1,600 disk galaxies that stare back at us from the edge of time. These are the cosmic twins of our Milky Way, possessing the same elegant spiral arms, the same central bulges, and the same rotating disks of orderly stars. On the surface, they look familiar and comforting, like looking at a photograph of our own cosmic backyard, but the terror of these images lies in the timing. These galaxies existed 9 to 13 billion years ago, at a time when the universe was in its violent, chaotic youth. According to every model we have built, these delicate, organized structures had no boson. Surviving in such a hostile era. Yet, there they are. Thousands of impossible mirrors reflecting a maturity that the universe should not have possessed for billions of years to come. This discovery came from a meticulous analysis of nearly 4,000 galaxies captured in Webb's earliest deep field observations. Astronomers were prepared to find a mess, a construction zone of half-built struct, ures and shattered fragments of matter. Instead, they found that 42% of these ancient objects were fully formed disk galaxies. To find such a high percentage of spirals in the early universe is a direct contradiction of the merger-driven model that has dominated cosmology for decades. We believed that the early universe was a place of extreme crowding and constant collision. In our emulations, small clumps of stars and dwarf galaxies would smash together with such frequency that any attempt to form a delicate spiral would be instantly ruined. We assumed that the grand design spirals, with their perfect symmetry and sweeping arms, were the products of a long, patient evolution that required billions of years of peace. James Webb looked back to the beginning of time and disk, averred that the universe was not patient at all. To create a disk galaxy like the Milky Way, specific and highly stable conditions are required. Gas must flow inward in a steady rhythmic stream, settling into a rotating disk without the interruption of major collisions. It is a process that requires a delicate gravitational choreography, where the rotation of the stars and the pressure of the gas find a perfect, sustainable balance. In the modern universe, this makes sense because space is vast and galaxies are relatively far apart. But 13 billion years ago, the universe was much smaller and cramped. Galaxies were packed closer together, and the environment was thick with the debris of the Big Bang. Spiral arms should have been smeared out of existence by tidal forces, twisted apart by the gravity of passing neighbors, or destroyed entirely by the frequent mergers of the era. Yet these 1600 twins look healthy, active, and undisturbed, as if they were living in a period of total cosmic serenity. Gabriel Perez Diaz, who illustrated several of these ancient mirrors, noted that if you were to remove the labels indicating their distance, a veteran astronomer could easily mistake them for galaxies in our own local neighborhood. They show no signs of recent violence or structural trauma. They appear as finished products, already spinning and already sporting the organized structure that we once thought took half the age of the universe to develop. This suggests that galaxies either assembled far faster than we ever imagined, or they possessed a resilience to violence that our current simulations fail to capture. The implications of this are staggering. If these disk galaxies could form and thrive this early, then the environments suitable for life were present billions of years earlier than we thought. Stable disks are the primary hosts for planetary systems, providing the metal-rich gas and quiet orbits necessary for rocky worlds to survive. If our twins were already in place when the universe was only 10% of its current age, then the history of life in the cosmos is far older and far more mysterious than we ever dared to dream. The standard model of galaxy formation assumed a slow, gradual growth, a timeline where the Milky Way was a late bloomer in a maturing universe. We saw ourselves as typical, believing our history was the blueprint for the rest of the cosmos. But James Webb has shown us that our history is just one version of a story that played out much faster elsewhere. We are seeing galaxies that have essentially fast-forwarded through the construction phase and jumped straight to maturity. It is as if the universe were a city that appeared fully built in a single night, rather than growing over centuries. This discovery forces us to reconsider the role of dark matter and the efficiency of early gravity. If 1600 galaxies could achieve this level of organization in such a short window of time, then the scaffolding of the universe must have been far more effective at directing matter than our math currently allows. These impossible mirrors raise uncomfortable questions about the nature of time itself in the early universe. When we look at a galaxy 13 billion light-years away, we are looking at light that has been traveling since the dawn of creation. We are seeing a ghost of the past that looks exactly like the present. This suggests that the infant universe was not as primitive as we assumed. It was structured, mature, and remarkably organized. The chaos we expected to find was placed by a symmetry that haunts the researchers who discovered it. Every spiral arm and every central bulge in those images is a challenge to the laws of physics. They are evidence of a cosmic maturity that occurred in a flash, a rapid assembly of complexity that we are only now beginning to quantify. The thousands of impossible galaxies fill the ancient sky like a vast gallery of mirrors, each reflecting the same mystery. How did the universe grow so fast? Why didn't the violent collisions of the early era destroy these fragile structures? These are the questions that keep astronomers awake at night. We have spent a century building a story of slow, laborious progress, and in a few months of observation, James Webb has replaced that story with one of sudden, brilliant arrival. The early universe was not a nursery of struggling infants. It was a theater of fully formed titans, spinning in the darkness with a grace that defies explanation. As you consider these 1,600 mirrors, imagine the sheer scale of the organization required to build them. In a universe that was supposed to be a chaotic soup of gas and heat, these galaxies found the focus to form spirals that would last for billions of years. They are the survivors of an era we thought was unsurvivable. They are the twins we never knew we had, living in a past that looks exactly like our present. Through the golden eye of Webb, we have finally seen the truth of the early sky, and it is a truth that makes our own galaxy seem less like a rare masterpiece and more like a standard part of a very old and very effigy ET design. The cosmic twins are a reminder that the universe has a memory of order that predates our own existence. They show us that the complexity of a spiral galaxy is not a reward for billions of years of waiting, but a fundamental possibility of the cosmos from its very earliest moments. As we continue to scan the deep field images, the count of these impossible mirrors will only grow, each adding more weight to the realization that we have misunderstood the clock of the stars. The mirrors are there, shining across the void, showing us a reflection of our home in a time when we shouldn't have been possible. They are the silent, spinning witnesses to a history that is much faster, much brighter, and much more disturbing than we ever imagined. 1,500,000,000 years after the Big Bang, a single object appeared in the golden mirrors of the James Webb Space Telescope that seemed to defy the very concept of time. This galaxy, named Alaknanda after a majestic Himalayan river, represents a moment in cosmic history that was previously thought to be impossible. When we look at Alaknanda, we are looking at the universe when it was a mere 1/10 of its current age. At this stage, according to every mathematical model of galaxy evolution, the cosmos should have been a messy construction site of half-formed shapes and chaotic clouds of gas. But Alaknanda does not look like a construction site. It looks like a finished masterpiece. It possesses perfect, sweeping spiral arms that wrap around a bright central bulge in an elegant, symmetrical dance. It is a mature, grand design spiral galaxy existing at a time when its peers were little more than disorganized clumps of matter. It is a galaxy that appears to have been built in a frantic time-lapse, bypassing the billion-year patience usually required for such structural perfection. Rashi Jain, a researcher who discovered this object, discovered that Webb's data challenged everything the scientific community knew about the speed of galaxy formation. Alaknanda stretches roughly 30,000 light-years across, not quite as large as the modern Milky Way, but significantly massive for its era. However, it is the density of its star population that is truly staggering. The galaxy contains 10 billion solar masses of stars. To build a population of 10 billion suns in just a few 100 million, RS requires a rate of stellar birth that borders on the incomprehensible. By doing the math, astronomers realized that Alaknanda must have been forming stars at a pace that dwarfs our current galactic environment. While our Milky Way creates 1 or 2 new stars every year, Alaknanda was churning out the equivalent of 60 stellar masses annually. half of the galaxy's entire stellar population RME'd in a brief window of just 200 million years. Imagine compressing billions of years of slow, methodical stellar evolution into a tiny fraction of that time. It is as if the galaxy was following a blueprint at triple speed, assembling its components with a terrifying efficiency. The structural symmetry of Alaknanda is perhaps its most disturbing feature for theorists. To create those distinct symmetric spiral arms, a galaxy needs density waves to propagate through its disk. These waves act like cosmic shepherds, compressing gas as they pass through and triggering the birth of the stars that light up the arms. In our traditional simulations, reaching the stability required to sustain these density waves takes billions of years of gravitational settling. The disk must become calm and the rotation must become orderly. Yet Alaknanda achieved this state of high-level gravitational choreography in what amounts to a cosmic blink of an eye. It emerged fully formed and stable when it should have still been a turbulent, formless cloud. Yogesh Wadadekar, a CO author of the study, summarized the crisis by stating that Alaknanda reveals the early universe was capable of far more rapid assembly than anyone anticipated. The presence of this galaxy proves that the standard models are not just slightly off, they are missing a fundamental mechanism of growth. There are two primary theories currently being debated to explain how such a time-lapse galaxy could exist. The first is that the early universe provided cold gas streams that flooded into the galaxy at rates far higher than any modern model predicts. This massive inflow of fuel would act like a high-pressure hose, feeding the stellar forge and forcing the galaxy to grow at an accelerated rate. The second theory suggests that a specific kind of collision, a minor merger, might have acted as a spark, jump-starting the rotation and triggering the spiral patterns earlier than usual. However, most collision-induced spirals are temporary and messy. Alaknanda's spirals look permanent, stable, and incredibly well established. The name Alaknanda is deeply symbolic in this context. In terrestrial geography, the Alaknanda River joins with the Mandakini to form the Great Ganga. In Hindi, the Milky Way word is Mandakini. By naming this distant galaxy Alaknanda, the researchers have created a link between two cosmic rivers, one ancient and one modern, that mirror each other across the vastness of time. We are seeing our own reflection in a mirror 13 billion years old, and the reflection is moving much faster than we are. The discovery of Alaknanda suggests that the early universe was a place of extreme efficiency, where the raw materials of reality were forged into complex structures with a speed that we are only now beginning to quantify. It is as if the universe were in a rush to create order out of the primordial chaos of the Big Bang through the gravitational lensing provided by Pandora's cluster, a massive collection of galaxies that acts as a natural magnifying glass. James Webb was able to capture the intricate details of Alaknanda that would otherwise be invisible. This cosmic magnification allowed us to see the delicate dust lanes and the bright clusters of infant stars that define the galaxy's spiral arms. Every photon of light from Alaknanda is a testament to a period of history that was much more active than we realized. The galaxy is a beacon of mature structure in a sea of ancient disorder. It stands as physical proof that the laws of gravity and gas dynamics can produce perfect in a fraction of the time we once thought necessary. It is a galaxy that refuses to wait for the slow turning of the cosmic clock, building itself in a time-lapse that has rewritten the history of the stars. As you contemplate the speed of Alaknanda's creation, think about the sheer energy that must have been released during its star-forming frenzy. 60 suns being born every year would create a landscape of constant supernova explosions and intense radiation, yet the galaxy maintained its delicate spiral shape throughout it all. It is a paradox of violent creation and stable structure. We are learning that the early universe was not just a simpler version of our own, it was a high-energy environment where the rules of growth were significantly different. The time-lapse galaxy is the first of many such discoveries that are forcing us to discard our old textbooks and start fresh with a new understanding of how the cosmos truly works. Alaknanda sits in the deep, cold infrared, its light stretched by billions of years of travel, yet its message is clear and urgent. It tells us that complexity is not a slow won prize, but a fundamental drive of the universe. The spiral arm. Continue to turn, the central bulge continues to shine, and the 10 billion stars continue to tell a story of a rapid, spectacular assembly. We are finally seeing the true face of the early universe, and it is a face of surprising maturity. The galaxy built in a time-lapse is a reminder that even at the beginning of time, the universe was already capable of producing the kind of beauty and order that we once thought was reserved only for the very old. Alaknanda is the ancient river of light that flows through our theories, carrying away the old certainties and replacing them with a new, breathtaking reality. 1 billion years after the Big Bang, a dragon opened its eyes in the deep infrared darkness of the infant cosmos. In the rich tapestry of Chinese mythology, Zhulong is the torch drawer. Gone, a celestial creature whose very breath and sight controlled the cycle of day and night. When it opened its eyes, light flooded the world. When it closed them, the darkness returned. It is a fitting name for a galaxy that blazes across the primordial void like a solar deity waking from a long, cold sleep. Discovered by researcher Mengyuan Shao while analyzing data from the James Webb Space Telescope's panoramic survey, Zhulong stands as a staggering monument to an era of the universe we are only just beginning to see clearly. The telescope was observing one region of the sky when it accidentally captured this remarkable object in pure parallel mode, a method where two instruments watch different areas of space simultaneously. What emerged from that accidental glance was a galaxy that mirrors our own Milky Way in shape, size and mass, yet it existed when the universe was only 1/14 of its current age. The terror of Zhulong lies in its perfection. According to the standard laws of cosmic time, less than 8% of cosmic history had passed when this light began its journey toward us. At such an early stage, galaxies should have looked like chaotic, shapeless blob, messy collections of gas and stars without any clear organization or internal structure. Yet, Zhulong displays a level of sophisticated architecture that should have taken billions of years to evolve. Its stellar disk spans 60,000 light-years, and it possesses two distinct, vibrant spiral arms that sweep out from a bright central bulge. It is an organized, spinning masterpiece in a time presumed cosmic anarchy. Even more disturbing is its weight. The stellar mass of Zhulong is 100 billion times that of our Sun. This means that the torch dragon contains more stars than the modern Milky Way, yet it formed in a tiny fraction of the time. We are watching the evolution of a titan occurring in fast forward, a biological scale growth applied to a galactic body. Christina W. Illiams, who leads the panoramic survey, noted that finding such rare and massive objects is essential to mapping the large areas of the sky that Webb is uniquely capable of seeing. Zhulong's detection was aided by a natural phenomenon known as gravitational lensing, where the mass of foreground galaxies acts as a cosmic magnifying glass, bending and brightening the light from the distant past. His allowed astronomers to see the dragon in unprecedented detail, revealing that its features defy every standard theory of formation. These theories predict a slow, arduous assembly, where galaxies start as tiny clumps and gradually merge over eons to build mass. Spiral arms, in particular, are delicate structures that are easily disrupted by the violent mergers and collisions that characterized the early universe. Yet, the arms of Zhulong look pristine and undisturbed, as if the galaxy avoided every collision through a streak of incredible luck, or perhaps as if spiral structures are far more resilient than our computer simulations have ever suggested. The central bulge of this galaxy contains an even deeper mystery. It is populated by older stars. This implies that the initial burst F-star formation that created the heart of the dragon must have occurred when the universe was even younger, perhaps only 700 or 800 million years after the Big Bang. The universe's timeline continues to compress under the weight of these discoveries. Zhu Long appeared fully formed, already spinning, and already sporting an organized structure as if it had been built off-screen and plaque. Aired into the early universe as a finished product, it challenges the very scaffolding of our cosmology, suggesting that the seeds of galaxies were much larger or more efficient than we ever dared to calculate. The dragon's eyes remain open, shining across 12.8 billion light-years of empty space, showing us a reflection of ourselves in a mirror that shouldn't have been manufactured yet. Imagine Saint landing on a planet within the outer reaches of Zhu Long's spiral arms. You would be surrounded by a density of stars that makes our own night sky look empty and dim. The central bulge would loom like a permanent golden dawn on the horizon, a testament to the billions of suns that ignited in a frantic rush of creation. Because Zhu Long is so massive and so young, the rate of supernova explosions within its disk would be high, seeding the galaxy with heavy elements at a pace that allows for complex chemistry to emerge almost immediately. In the dragon's wake, the raw materials for planets and life were being forged while the rest of the universe was still struggling to form its first stable structures. It is a place where time seems to have no meaning, where the ancient and the modern are merged into a single glowing entity. The discovery of Zhu Long adds to a growing mountain of evidence that James Webb is finding mature galaxies in the early universe with an alarming frequency. Each of these observations demands an explanation that our current science cannot fully provide. If the Dragon Galaxy can exist in such a finished state so early, then our understanding of how gravity pulls matter together is fundamentally incomplete. We are looking at a cosmos that developed with a ferocity and a purpose that we are only just beginning to name. Mengyuan Shao summarized the significance of the find by pointing out just how much this object resembles our own home. We are looking at our own reflection in the deep past, seeing what the Milky Way might have been if it had existed impossibly early. The torch dragon is a reminder that the cosmic dawn was not a slow brightening but a sudden, brilliant flash of complexity that left the darkness behind in a single magnificent blink. As you reflect on the dragon of the ancient dawn, let the rhythmic scale of its existence settle into your mind. It is a creature of light, born from a time of shadows, a massive and orderly inhabitant of a chaotic era. Its light has traveled for nearly 13 billion years, passing through the expanding voids and past the births and deaths of a trillion other stars, just to strike the golden mirror of a telescope built by a species that hadn't even been dreamt of when the dragon first opened its eyes. We are the recipients of its ancient message, the witnesses to its impossible maturity. Zhu Long is not just a galaxy. It is a challenge to our perception of history, a silent sentinel that watches us from the beginning of time. The dragon continues to shine in the deep infrared, its spiral arms turning in a slow, majestic rotation that has lasted for most of the history of the universe. It is a masterpiece of the early heavens, a golden anchor in the swirling mists of the primordial D. James Webb has pulled back the curtain on this ancient era and found that the dragons were already there, waiting in the light, fully formed and brilliant. We are no longer looking at a universe of slow progress, we are looking at a universe of sudden and spectacular arrival. The dragon's eyes are open, and in their glow we are seeing the true face of our origins, a face that is far more far more massive, and far more beautiful than we ever expected to find in the darkness of the dawn. Something glows in the extreme early universe, a haunting light that emerged just 100 million years after the Big Bang. Scientists cannot tell you what it is, but they have given it a name, Kapuro, the bullhead, discovered in the deep infrared images of the James Webb Space Telescope. This object sits at a distance that represents less than 1% of the universe's current age. At this point in history, the cosmic dark ages had barely ended. The first stars were supposed to be just igniting isolated sparks of light in a vast neutral fog of hydrogen. Nothing complex should exist yet. No massive structures, no organized cities of stars, and certainly nothing as brilliant as what the telescope has found. Kapuro exists anyway, blazing like a cosmic beacon that refuses to care about the constraints of human physics. It is one of the most puzzling discoveries of our time, a riddle written in photons that challenges the very boundaries of our knowledge. Giovanni Gandolfi, an astrophysicist who studies this strange entity, noted that Kapuro is as interesting as it is promising, yet it refuses to be categorized. When scientists look at an object this far away, they usually have a set of labels ready: galaxy, black hole, or star cluster. But Kapuro resists all of them. There are three primary possibilities currently being debated in the halls of science, and each one is as unsettling as the next. The first possibility is that Kapuro is an extremely early galaxy, born when the universe was barely breathing. If this is true, it is forming stars at an impossible rate, creating a collective light that outshines everything in its era. This explanation would require us to completely rewrite our theories of galaxy formation, as stars simply shouldn't be able to assemble this fast. The second possibility is that it is a supermassive black hole, a quasar that is actively feeding on primordial dawn gas. But this too breaks our models. Where did such a monster come from? How did it grow so massive in only 100 million years? There simply wasn't enough time for a seed to sprout into a giant. The third possibility is perhaps most troubling. Kapuro is something entirely new. It could be a class of cosmic objects we've never seen before, a phenomenon unique to the extreme conditions of the early universe that no longer exists in our modern era. Unknown categories are the things that keep scientists awake at night, as they represent a total gap in our understanding of reality. Mohammed Latif, an astrophysicist who has evaluated the data, called it one of the most intriguing and puzzling discoveries of the James Webb era. He noted that whatever way you interpret the data, you are pushing the boundaries of knowledge to the edge of a cliff. If it is a galaxy, our timelines are wrong. If it is a black hole, our growth models are wrong. And if it is something else, then we don't understand the infant universe at all. The name Kapuro, which means bullhead in Italian, was given to the object because of its unusual appearance in the processed images. It does not look like the symmetrical spirals or the smooth ellipticals we are used to seeing. Instead, it shows a bright, dense central region with odd, fainter extensions that give it a peculiar, almost animal-like morphology. Even visually, it refuses to fit into the boxes we have built for the heavens. Distance measurements place it at a redshift of 13 or higher, meaning its light has been traveling through the expanding void for nearly 13.7 billion years. When that light began its journey, the universe was in its absolute infancy, yet Kapuro was already a mature and powerful presence. It sits in the data like a riddle that is clear enough to detect but mysterious enough to confound every attempt at identification. The research team has requested additional time with the James Webb Telescope to perform spectroscopic analysis on the bullhead. By breaking its light into component wavelengths, they hope to find the chemical signatures of its power source. If they find the heavy elements of dead stars, they will know it is a galaxy. If they find the signature of superheated plasma spinning at the edge of a void, they will know it is a black hole. But the is a quiet apprehension that they might find something else entirely, a spectrum that looks like nothing we have ever seen. They are also seeking Kapuro's siblings. If the bullhead is a unique fluke, it might be explained away as a cosmic outlier. But if the early universe is populated by a whole herd of these objects, then the cosmic dawn was a much stranger and more crowded era than we ever imagined. As you reflect on the riddle of the bullhead, imagine the environment of the universe 100 million years after its birth. It was a place of pristine gases and raw energy, where the first structures were only just beginning to pull themselves together out of the darkness. In this world of simplicity, Kapuro was an island of complexity. It was a finished product in a universe of raw materials. Through the golden eye of Webb, we are seeing the light of an object that defies the very clock of the stars. It is a reminder that the universe does not always follow the neat, linear paths we have designed for it in our textbooks. Sometimes, the most important things appear before they are supposed to, challenging us to expand our minds to fit a much larger reality. The mystery of Kapu. RO is representative of the disturbing theme that runs through the James Webb mission. The telescope was built to find the first galaxies, but it is finding things that shouldn't be there at all. It is uncovering a history that is faster, brighter, and much more bizarre than our models predicted. The bullhead is a silent sentinel at the very edge of time, watching the beginning of everything. Why? An intensity that we are only just beginning to measure. Its light has crossed the entire history of the cosmos to reach our mirrors, a 13-billion-year-old message that tells us we are only just beginning to learn the alphabet of the stars. Kapuro sits in the deep, cold infrared, a glowing anomaly that demands an answer. It is the ultimate riddle of the bullhead, a light that shouldn't exist, in a time that wasn't ready for it. As the spectroscopic data eventually comes in, we may find ourselves forced to discard our most fundamental beliefs about the early universe. But for now, Kapuro remains a beautiful and terrifying mystery, a bright point of confusion in the darkness of the ancient dawn. It is a testament to the fact that the more we see of the universe, the more we realize how. Much is still hidden in the shadows, waiting for a telescope cold enough and sensitive enough to reveal the impossible truths of the beginning. A new species has been discovered in the deep infrared reaches of the early universe. Astronomers have given them a name as simple as it is haunting: the little red dots. As the James Webb Space Telescope scanned the ancient horizons of cosmic dawn, Roffle, 600 million years after the Big Bang, it began to find these mysterious objects in staggering numbers. They appear as tiny, compact, and distinctly red points of light scattered throughout every deep field image, looking like cosmic copies stamped from the same enigmatic template. To the uninitiated, they might seem like mere specks of dust on the camera's lens, but to the scientific community, they represent a profound and unexplained population of objects that shouldn't exist in such abundance. These are not rare flukes or isolated anomalies. They are a swarming presence in the infant cosmos, a new category of celestial entity that challenges our understanding of how both galaxies and black holes began their lives. The name describes them perfectly, yet it belies the complexity of the mystery they represent. Their distinct red color is a result of the immense distance they have traveled across the expanding universe. As their light journeyed toward us for over 13 billion years, the very fabric of space stretched its wavelengths, shifting them from the vibrant colors of their youth into the long, low frequencies of the infrared. This is a common effect for all NT objects, but the little red dots are different because of their extreme compactness and their startling uniformity. In the high-resolution images provided by Webb's Golden Mirror, they do not show the sprawling spiral arms of a galaxy or the diffused glow of a typical star cluster. Instead, they remain tight, brilliant, and red, appearing as point-like sources of energy that concentrate a massive amount of power into an impossibly small volume of space. The real mystery of the little red dots lies in what is happening beneath their crimson veils. Initial observations suggested they might be small, very distant galaxies that were forming stars at extreme rates, but as spectroscopic analysis began to peel back the layers, the findings became much more unsettling. Many of these dots show unmistakable signatures of active, supermassive black holes. These monsters are accreting matter and spewing out energy with a ferocity that outshines their entire host galaxies. However, they are far too small to be the typical quasars we see in the later universe, and they are far too numerous to fit into any existing model of black hole growth. We are seeing a universe that was populated by mini-monsters in its youth, a population of feeding black holes that appeared almost simultaneously across the primordial darkness. One particular little red dot, which researchers have named Virgil, displays a Jekyll and Hyde behavior that has left astronomers in a state of quiet confusion. When observed at certain wavelengths, Virgil looks like a normal, quiet young galaxy, minding its own bus, Enos, and slowly forming a modest population of stars. But when the telescope switches to different infrared frequencies, the good side of the galaxy vanishes and a monster emerges. Beneath a thick cocoon of cosmic dust, a heavily obscured supermassive black hole is pouring out immense quantities of energy. This suggests that the little red dots are actually Jekyll and Hyde objects, wearing disguises that hide their true, violent natures. If Virgil is representative of the hundreds of other dots found by Webb, then we have been blind to a massive population of hidden monsters that dominated the early universe. The timeline of these objects is equally perplexing. The little red dots appear in great numbers around 600 million years after the Big Bang, reach a peak in their popule, and then seem to vanish by the time the universe reaches 2 billion years of age. They are a transient species, a phase of cosmic evolution that occurred once and then disappeared forever. This raises the question of what they became. Did these little red dots eventually grow into the massive galaxies and black holes we see in our modern neighborhood, or were they a dead-end branch of the cosmic tree? Identifying their descendants is one of the primary goals of current research, but so far the transition remains a mystery. It is as if a whole generation of the universe's inhabitants went through a spectacular, red-tinted puberty and then emerged as something unrecognizable to our current theories. Some researchers believe that the little red dots are actually dusty quasars, massive black holes wrapped in such thick blankets of soot and gas that only their heat can escape. The dust absorbs the blinding radiation of the black hole and re-emits it as infrared light, creating the compact red appearance that Webb detects. This would explain why they are so bright and so small. However, other scientists think they might be compact starbursts, regions where stars are forming at such extreme densities that the environment becomes a high-pressure furnace of radiation. A third, more exotic possibility involves black hole stars, hypothetical objects where a black hole sits inside the core of a massive star, feeding on its host and radiating energy in a hybrid process that our modern universe no longer supports. The sheer abundance of these objects is perhaps the most disturbing aspect of the discovery. Every time James Webb looks deep into a patch of empty sky, it finds dozens more of these little red dots. They are a common phenomenon, not a rare exception. This suggests that the process that created them, whether it was a rapid growth of black holes or a frantic burst of star formation, was a fundamental part of how the early universe operated. We are a species of mystery that was the dominant form of complexity in the ancient dawn. The fact that we didn't even know they existed until Webb opened its infrared eye shows just how much of our own history has been hidden in the shadows of the long wavelengths. As you contemplate these tiny red specks of light, imagine the scale of the power they contain. Each dot is a powerhouse of energy, a concentrated point of creation or destruction that helped shape the evolution of the first galaxies. They are the seeds of the cosmos, glowing with a crimson heat that has been traveling since the beginning of time. Through the data provided by Webb, we are finally beginning to penetrate their disguises, but every answer only leads to more questions. We are finding that the infant universe was a much busier and much more crowded place than we ever suspected, filled with a diverse population of objects that refuse to follow our modern rules. The little red dots are a reminder that the universe has many chapters we have yet to read. They haunt the deep field images like ghosts of a forgotten era, silent and red against the blackness of the void. They are a new species of mystery, a category. Existence that demands we rethink everything we know about how the first massive structures in the cosmos were born. As James Webb continues to collect data on these objects, we may finally learn the truth about Virgil and its siblings, but for now they remain as they have been for 13 billion years, compact, brilliant and mysterious, the little red dots that pulse with the hidden energy of the ancient dawn. In the vast, silent theater of the early universe, where light and shadow perform a dance that spans the beginning of time, James Webb has introduced us to a character with a split identity, This is Virgil, a galaxy that exists 600 million years after the Big Bang, and it has become one of the most significant puzzles in modern astronomy. What makes Virgil so compelling, and perhaps so unsettling, is its dual nature. It is a galaxy with two faces, a celestial entity that appears to be two completely different things depending on how you look at it. When astronomers observe Virgil through certain infrared filters, they see a mild-mannered, typical young galaxy. It appears to be a quiet collection of stars, minding its own business in the primordial soup, forming new stellar populations at a modest and predictable rate. But when the telescope shifts its gaze to the mid-infrared, the mask falls away, the quiet, innocent galaxy vanishes, and in its place emerges a cosmic monster, a heavily obscured supermassive black hole pouring out immense quantities of energy that defy every rule of its era. This discovery is a profound lesson in the limitations of our own perception. Most objects in the cosmos are consistent. A star shines as a star across most wavelengths, and a typical galaxy maintains its identity whether viewed in visible or infrared light. But Virgil refuses to choose a side. It is the ultimate expression of the little red dot phenomenon, representing a population of objects that, where disguise is so effective, they have remained hidden from our eyes for the entire history of human observation. The research team that first analyzed Virgil's data described it as a Jekyll and Hyde system. On its good side, it presents the face of a peaceful, star-forming nursery. This is the version of Virgil that fits neatly into our existing textbooks. It looks like the kind of small, emerging structure we expected to find in the early universe, a hum, the beginning for what might one day become a massive spiral. However, the monster side of Virgil tells a much more disturbing story. Through the lens of Webb's MIRI instrument, which sees into the mid-infrared, the galaxy's true nature is revealed. At these longer wavelengths, the cosmic dust that surrounds the galaxy's center becomes transparent, and the light from a hidden accretion disk blaze into view. This is the signature of a supermassive black hole that is feeding aggressively, consuming gas and dust at a rate that should be impossible for a galaxy of its size and age. The radiation from this feeding process is so intense that it would likely sterilize the entire galaxy, yet from the outside, and at different wavelengths, this violence is completely hidden. Virgil is a master of deception, a cosmic entity that hides its most terrifying feature behind a veil of soot and shadow. The reason for this dual identity is the sheer amount of dust that clogs the center of the galaxy. Thick clouds of silicates and carbon-rich soot surround the central black hole, acting as a perfect filter. These clouds are dense enough to absorb the high-energy, ultraviolet, and visible light produced by the black hole's feast, remitting that energy as heat, the very infrared radiation that James Webb was built to detect. This means that for billions of years, we have been looking at a good side that was essentially a lie, or at least a very incomplete truth. We were seeing the stars in the outer regions of the galaxy while remaining totally blind to the monster at the core. Virgil forces us to ask an uncomfortable question. How many other quiet galaxies in the ancient dawn are hiding similar secrets? Are we living in a universe filled with hidden monsters, masquerading as mild-mannered star-formers? The implications of Virgil's two faces extend far beyond a single galaxy. If one object can hide its black hole effectively, it suggests that our census of the early universe is fundamentally flawed. We may be significantly underestimating the number of supermassive black holes that existed in the first billion years after the Big Bang. This could finally explain one of the greatest mysteries in cosmology, how black holes grew so large so quickly. If they spent their early years wrapped in thick cocoons of dust, they could feed continuously and aggressively without the radiation pressure of their own light blowing away their food source. The dust shields them, allowing them to gorge in secret until they reach a massive size. Virgil is a snapshot of that secret feeding process, a moment of transition where the monster is still hidden behind the mask of the galaxy. As you contemplate Virgil's dual nature, let your mind drift into the mechanics of this cosmic masquerade. Gene, the center of that galaxy, a place of absolute violence where matter is being torn apart and converted into pure energy at the edge of a void. And then, imagine the outer edges of that same galaxy where cool gas clouds are slowly collapsing to form the next generation of stars. These two realities exist simultaneously, separated only by a layer of dust and the wavelength of the light we choose to use. It is a reminder that what we see in the cosmos depends entirely on how we look. Relying on one type of light creates a dangerous blind spot, a hole in our understanding that Virgil has finally exposed. We are learning that the early universe was not a simple place of emerging light, but a complex stage of costumes and disguises. The Virgil discovery has astronomers rethinking their sky. Mapping strategy. We can no longer take a galaxy at its face value. Every quiet, red-tinted dot in the deep field images must now be scrutinized for a monster side. This requires more time with instruments like MIRI, which can penetrate the dust cocoons of the ancient dawn. It requires us to look for the subtle flickers and shifts in energy that reveal a hidden presence. Virgil is the prototype for a new way of seeing, a guide that teaches us to look beneath the surface of the little red dots and find the truth hidden in the heat. It is a galaxy that has shattered our confidence in the simplicity of the early universe, replacing it with a reality that is far more vibrant, violent, and deceptive. The two faces of Virgil also speak to the coevolution of galaxy and black holes. In the modern universe, these two components seem to have reached a balance, growing together in a predictable relationship. But in Virgil, the balance is gone. The black hole is the dominant partner, a hidden king that dictates its host's fate from behind a curtain of dust. This reversal of the modern order suggests that, in the beginning, the monsters came first, or at least they grew much faster than the cities that housed them. The galaxy is merely a shell, a mask that hides the true driver of cosmic evolution. Virgil is proof that a galaxy's heart can be a monster even when the face appears peaceful. In the deep infrared silence, Virgil continues its dual existence. It remains a ghost of the past, a 13-billion-year-old enigma that James Webb has finally unmasked. It tells a story of a universe that was much more active and much more cluttered than we ever dared to imagine. As we continue to scan the horizon for Virgil's siblings, we must be prepared for what we find. The masks are beginning to slip, and the monsters of the ancient dawn are stepping out from the shadows revealed in the golden glow of the mid-infrared. Virgil was the first to show us its two faces, but it will certainly not be the last. The cosmic costume party is over, and the true nature of the early universe is finally coming into focus, a reality that is as beautiful as it is disturbing, hidden no longer from the eyes of those who know where to look. In the silent architecture of the cosmos, we have long believed in an invisible foundation, a ghost-like substance that outweighs all the stars, planets, and nebulae combined. This is dark matter, the gravitational scaffolding upon which the entire universe was meant to be built. For decades, our standard model of cosmology rested on the absolute necessity of this unseen weight. We believed that after the Big Bang, dark matter was the first thing to clump together, creating vast invisible wells of gravity that acted like ADLs for normal matter. Only after these dark matter halos reached a sufficient size could gas fall into them, cool down, and begin the long, laborious process of forming a galaxy. It was a perfect, logical sequence that dictated the speed of cosmic history. But as the James Webb Space Telescope peers deeper into the ancient sky, it has found galaxies that have appeared far too early, growing massive and mature before the dark matter scaffolding was even ready. The foundation is shaking, and for the first time in modern history, we are witnessing the cracks in the theory that held our reality together. The problem is one of simple, unforgiving timing. Dark matter structures, while powerful, are governed by the slow pull of gravity over vast distances. According to our most sophisticated computer simulations, these invisible halos need hundreds of millions of years to grow large enough to host a massive galaxy. By the time the universe was 800 million years old, the scaffolding should have been in its skeletal stages, thin, fragmented, and incapable of supporting a heavyweight occupant. Yet, James Webb has discovered galaxies like Z-Food 7329, which sit in that ancient era. With a stellar mass greater than that of the modern Milky Way, it is a galaxy that exists when it theoretically cannot. It is a massive, finished building standing in a construction zone where the foundation hasn't even been poured. This is not just a minor anomaly, it is a direct challenge to the standard model of cosmology, suggesting that either our understanding of dark matter is wrong, or the universe has a way of building itself that doesn't require the scaffolding we thought was mandatory. Claudia Lagos, an associate professor who has analyzed these impossible structures, noted that having such extremely massive galaxies so early in the universe poses significant challenges to our entire framework of thought. The Milky Way spent over 13 billion years gradually building its population of stars through mergers and steady growth. To see a galaxy reach that same level of mass in less than 1 billion years is like watching a mountain rise out of a flat plain in a single afternoon. It defies the speed limits of physics. Star formation requires gas to cool and collapse, a process that takes time. To bypass these limits, the early universe must have been far more efficient or more violent than our models allow. The existence of these titans suggests that the seeds of the cosmos didn't wait for dark matter to provide a home. They created their own, igniting with a ferocity that has left theorists scrambling for answers. When we look at the data from Webb, we see 3 distinct possibilities, each more unsettling than the last for the scientific establishment. The RST is that galaxy formation is simply much more efficient than we ever dared to dream. Perhaps in the high-density environment of the early universe, gas was converted into stars at a rate that bypasses the need for large dark matter wells. The second possibility is that dark matter itself behaves differently than we assumed. Maybe it clumps much faster or interacts with itself in ways that accelerate the growth of the invisible scaffolding. But the third possibility is the one that causes the most fear in the halls of science, the idea that our understanding of dark matter is fundamentally flawed. If galaxies can form this quickly and this massive without the predicted halos, then the invisible foundation might not be the primary driver of cosmic evolution at all. We may be looking for a ghost in a machine that runs on a completely different kind of engine. This crisis of the scaffolding is not just about a few distant galaxies. It is about the story we tell ourselves about how we came to be. If the dark matter timeline is wrong, then the entire history of the universe needs to be recalculated. The expansion rate, the influence of dark energy, and the age of the stars are all tethered to this model. When the scaffolding cracks, the whole structure of modern cosmology begins to lean. We are finding that the infant universe was not a smooth, slow-growing garden, but a place of sudden, explosive maturity. Galaxies like Z-Food 7329 are the evidence of a fast-forward universe where complexity emerged in a flash, ignoring the slow rules of gravitational assembly that we see in our textbooks. We are forced to ask if gravity itself worked differently in those first few 100 million years, or if there is a hidden force we have yet to name that pushed the stars into being. As you reflect on these cracks in the cosmic foundation, imagine the scale of the error we may have made. For 50 years we have searched for the dark matter particle, assuming it was the silent architect of everything we see. We built massive detectors deep underground and launched telescopes into the void, all to confirm the presence of the scaffolding. But James Webb has shown us that the buildings were already finished before the architect even arrived at the site. This suggests that the universe has a memory of order that is far deeper and more resilient than our current theories account for. The impossible galaxies are not just bright spots in a telescope. They are the heavy, solid proof that reality is more mysterious than the math we use to describe it. We are seeing a breakdown of the status quo, a moment where the observations have finally outpaced the imagination of the theorists. The research teams are currently trying to save the model by tweaking the parameters, adjusting the efficiency of star birth, or suggesting that early dark matter was stickier than modern dark matter. But each new Webb discovery adds more weight to the cracks. More massive galaxies are appearing at even earlier dates, pushing the limits of tweaking until the theory becomes a house of cards. We are approaching a revolutionary moment in astronomy, a point where the old scaffolding must either be reinforced with entirely new physics or torn down to make way for a different understanding of the dark. The universe did not follow our blueprint. It built itself with a speed and a scale that makes our most advanced simulations look like toys. In the deep infrared dark, the impossible galaxies continue to shine massive and mature, anchored to a past that shouldn't be able to hold them. They are the silent witnesses to a failure of the standard model, but also to the magnificent efficiency of the actual cosmos. We are learning that the universe is not a fragile thing that needs an invisible hand to guide it. It is a powerhouse of self-assembly that can create a Milky Way-sized titan in the blink of a cosmic eye. The scaffolding may be cracking, but the stars are still there, glowing with a truth that we are only just beginning to learn. We are the witnesses to a crumbling theory and the birth of a new one, watching as the golden eye of Webb reveals a universe that is far more independent, far more ancient, and far more powerful than we ever dared to believe. In the vast, silent theater of the cosmos, where everything seems to move in a slow and predictable dance, James Webb has confirmed a nightmare that had long been confined to the realm of theoretical physics. Deep within a pair of interacting ring galaxies known as the Cosmic Owl, 9 billion light-years away, a monster has gone off script. It is a supermassive black hole with the mass of 10 million suns, but it no longer sits on its central throne. Instead, it is a runaway, an exile hurtling through the intergalactic void at a staggering speed of 2.2 million miles per hour. This is the first confirmed case of a supermassive black hole being violently yeeted from its home galaxy, and the implications are as terrifying as they are profound. We are witnessing a cosmic cannonball fired from the heart of gravitational chaos racing into the darkness at nearly 1,000 kilometers per second, fast enough to permanently break free from the gravity of its former home. The velocity of this runaway monster is so extreme that it boggles the mind. At 2.2 million miles per hour, this black hole is traveling at roughly 3,000 times the speed of sound here on Earth. If you were to place this object at the distance of our own sun, it would cross the entire solar system in a matter of days. For decades, astronomers had predicted that such escapes should occur, theorizing that the violent collisions of galaxies could occasionally dislodge their central anchors. But until the James Webb Space Telescope turned its golden eye toward the Cosmic Owl, these runaways were merely ghosts in our computer simulations. Webb's infrared sensitivity has finally transformed this theoretical prediction into a terrifying reality, revealing a wake of destruction and creation that traces the black hole's escape path across the stars. The evidence for this exile is written in the gas and starlight of the intergalactic medium. As the BLACK hole barrels through space, it does not travel silently. Like a massive ship plowing through a calm ocean, it creates a galaxy-sized bow shock at its front. This shock wave compresses the tenuous gas of space, heating it to millions of degrees and creating a brilliant, glowing signature that Webb's near-spec instrument was able to dissect with surgical precision. But even more remarkable is where the black hole leaves. Behind the monster stretches a narrow, razor-thin trail of newly formed stars, a cosmic umbilical cord nearly 200,000 light-years long. This contrail is essentially a stellar nursery in motion, as the compressed gas behind the shockwave cools and collapses into infant suns. The black hole is effectively a cosmic plow, tilling the intergalactic soil and soil. The seeds of stars in a place where they have no business existing. The force required to launch an object of 10 million solar masses at such speeds is almost beyond comprehension, Astronomers believe this runaway was the result of a triple merger or a violent gravitational recoil. Imagine two galaxies merging, their central black holes forming a tight binary pair, dancing around each other in a death spiral. Then, a third galaxy arrives, bringing its own supermassive black hole into the fray. This three-body interaction is inherently unstable. In the resulting gravitational tussle, two of the black holes might merge, releasing an asymmetrical burst of gravitational waves that imparts a powerful kick to the survivor. Alternatively, the third black hole might act as a gravitational slingshot, stealing momentum from the others and flinging one of them out of the system entirely. In the case of the cosmic owl, the result was a permanent exile, sending a 10 million sun monster on an endless journey into the void. This discovery changes everything we thought we knew about the stability of galactic centers. For a century, we treated supermassive black holes as permanent, unmoving G-fixtures that shape their galaxies from a central, immovable point. But the runaway and the cosmic owl proves that even the most massive objects can be set adrift by the whims of gravity. It forces us to ask, how many other orphaned black holes are currently wandering undetected through the universe? If galactic mergers are as common as our theories suggest, then the intergalactic void might be far more crowded than we realized. Invisible wanderers, millions of solar masses in size, may surround us, drifting in the darkness between galaxies with nothing but a faint trail of orphaned stars to mark their passing. James Webb's ability to see this runaway is a testament to the power of the infrared spectrum. Invisible light, the black hole itself, is of course black, an invisible void that swallows light. But the heat of the gas it displaces and the unique colors of the young stars it creates are visible to Webb's sensitive mirrors. By measuring the Doppler shift of the gas at the tip of the wake, researchers were able to confirm the black hole's incredible speed. They saw a sudden, massive jump in velocity that could only be explained by a heavy object plowing forward at supersonic speeds. It is a dynamical signature that is crystal clear, leaving no doubt that the monster is truly on the move. As you reflect on the flight of this runaway monster, imagine the sheer loneliness of its journey. It has left behind the billions of stars that once orbited it, trading the bustling center of a galaxy for the absolute desolation of the intergalactic void. It travels alone, carrying only a small cloud of material within its immediate grasp, followed by a trail of stars that it can never truly call its own. It is a supermassive exile, a survivor of a cosmic collision that has been cast out into the forever dark. And yet, even in its exile, it is a creator. The stars it leaves behind will shine for billions of years, a permanent reminder of the moment a monster tore through the silence of space and changed the map of the heavens. The discovery of RBH-1, the first confirmed runaway, is just the beginning of a new chapter in our exploration of the deep. It reminds us that the universe is a restless and often violent place where even the anchors can be broken. As we continue to use the James Webb Telescope to scan for these needle-like streaks in the darkness, we are to find that the cosmic owl is not unique. We are living in a universe of movement and upheaval, where the monsters are on the loose and the stars are being born in the wake of their flight. The runaway monster is a haunting and magnificent truth, a 2.2 million mile-per-hour reminder that in the vastness of the cosmos, everything, even a black hole, is searching for a place in the dark, in the profound stillness that follows these staggering revelations. We are left to piece together a new and unsettling image of the cosmos. As we have traveled from the violent, flickering heart of our own Milky Way to the impossible mirrors of the early universe, a single, undeniable pattern has emerged. The story of our origins is not the one we were told. We have long viewed the history of the universe as a slow and patient film, a billion-year epic of gradual cooling, clumping, and assembly. But the James Webb Space Telescope has shown us that this film has been playing at double speed. We live in a fast-forward universe, a reality where complexity, structure, and massive power appeared in a sudden, brilliant flash that defied every law of cosmic aging. The fast-forward universe is the new company, Smig Truth, and it demands that we rethink everything we thought we understood about the clock, of the stars, and our own place within the timeline of existence. This new truth is written in the light of galaxies that reached maturity when they should have been infants. It is spoken in the silent presence of supermassive black holes that gorged themselves to greatness before the universe was even a billion years old. The standard model of galaxy formation, which relied on the slow, methodical accumulation of mass over eons, has been shattered by the sight of 1,600 spiral galaxies spinning with perfect grace in the primordial dawn. We believed that the grand design of a spiral galaxy was a hard-won prize, earned through billions of years of gravitational settling. But Webb has shown us that the universe was capable of perfection early on. The time-lapse assembly of galaxies like Alexander and Zhulong suggests that the early cosmos was not a chaotic nursery, but a high-efficiency forge where the blueprints of reality were executed with a ferocity. We are only just beginning to measure. The implications of this accelerated history are as beautiful as they are disturbing. F galaxies reached maturity billions of years earlier than we predicted. Then the conditions suitable for life were also present much sooner. We once believed that the universe needed nearly 10 billion years to produce enough heavy elements and stable environments for rocky planets to form and life to take root. We saw ourselves as early arrivals in a young universe, but James Webb's findings suggest we might actually be late to the party. If stable metal-rich disk galaxies existed 13 billion years ago, then the history of life in the cosmos could be twice as long as we assumed. Entire civilizations could have risen, flourished, and vanished into the darkness, while our own star was still nothing more than a cold cloud of gas. The silence of the Fermi paradox, the question of why we have yet to hear from others, becomes much more ominous when we realize that the universe has had plenty of time to fill itself with voices. The failure of the invisible scaffolding of dark matter to match the speed of these early titans is perhaps the most significant crack in our old understanding. We built our cosmology on the idea that dark matter dictated the pace of growth, but the observed ions show that the stars didn't wait for permission. They ignited and clustered with an independence that suggests our models are missing a fundamental force or a hidden efficiency in the laws of gravity. We are finding that the universe is more self-reliant and more creative than our math allows. The fast-forward nature of the early universe tells us that the transition from the Big Bang to complexity was not a struggle, but a sudden and spectacular arrival. We have misunderstood the metabolism of the cosmos, assuming a slow crawl where there was actually a sprint towards structure. As we look at the runaway monsters and the little red dots, we see a universe that was much busier and much more cluttered than we ever dared to imagine. The ancient dawn was a theater of disguises, where galaxies wore two faces and black holes grew in secret behind veils of dust. The Jekyll and Hyde nature of objects like Virgil shows us that we can no longer trust our surface-level observations. We must look deeper into the long wavelengths of the infrared to find the true drivers of cosmic evolution. The monster-first theory, the idea that supermassive black holes preceded or outpaced their galaxies, is gaining ground, suggesting that the anchors of the universe were forged in the fire before the ships were even built. This reversal of the modern order is a stark reminder that the rules of the game have changed over cosmic time. The atoms in your body, the carbon, the iron, the oxygen, were forged in the hearts of stars that may have lived and died in this frantic early epoch. We are the products of an efficiency we did not know existed. The Big Bang's chemical path to biology is shorter and more direct than we calculated. This realization humbles us, for it shows that our previous theories were built on a limited view of a much larger and faster reality. We were looking at the universe through a keyhole, and James Webb has finally kicked the door open. What we found on the other side is a universe that is stranger, more violent, and more magnificent than anything we could have invented. It is a reality where delicate structures persist through chaos, and where giants roam the empty voids at millions of miles per hour. As you sit in the quiet of the present moment, think about the photons from the cosmic dawn that are hitting the telescope's mirrors right now. They have traveled for 13 billion years, crossing the expanding voids and witnessing the entire history of the stars, just to deliver a message of impossible speed. They tell us that the universe is not a museum of static objects, but a living, breathing, and rapidly shifting entity. The fast-forward universe is a place where the impossible is simply a truth we haven't yet learned how to measure. We are the witnesses to a grand reconstruction of history, a time when the maps are being redrawn and the clocks are being reset. The discoveries of James Webb are not just scientific milestones, they are a shift in human consciousness, a new way of understanding our relationship to time and the infinite. The golden eye of Webb continues to stare into the deep, cold dark, with every new data the new cosmic truth becomes clearer. We are part of a story that is much older and much more energetic than we knew. The whispering scientist began this journey by looking at the heartbeat of our own galaxy, but we have ended by realizing that the entire universe is beating with a rhythm of rapid, brilliant assembly. The horror of impossible discoveries is slowly being replaced by the awe of a deeper understanding. We are learning to speak the language of the infrared, to see the heat of the first dawns, and to accept that the universe is far more capable than we ever gave it credit for. James Webb looked deep into the Milky Way and found a screaming heart. It looked deep into the early universe and found a fast-forward history. What it found is disturbing because it challenges our control over the narrative of the past, but it is also a gift, a window into the raw, unfiltered truth of our origins. The cosmic film continues to play, and though we cannot slow it down, we can finally see the beauty in its speed. We are the children of a rapid dawn, the observers of a magnificent and accelerated history. And as we continue to look into the dark, we do so with the knowledge that the universe is still full of secrets, still full of monsters, and still, after all this time, capable of showing us something that we never thought possible. Through the silent infrared glow, the fast-forward universe continues its frantic, beautiful work. The spiral arms turn, the black holes feed, and the runaway exiles race toward the unknown. We are here, at the end of the first chapter of this new story, ready to listen to the whispers of the next. The telescope has revealed the truth, and though it may be terrifying to the theories of the past, it is the only path toward the future of our understanding. The journey into the deep is just beginning, and the stars are waiting for us to catch up to their impossible speed. Thank you for traveling through the dark with me. Sleep now while the universe continues its ancient, brilliant sprint toward the dawn.